The electricity grid in Great Britain was largely designed for a top-down, one-way power flow. Government energy targets and European energy scenarios point towards a situation where the opposite may well be true. At Western Power Distribution, we're looking at the future of networks from a strategic perspective. We have projects looking at validating future investment plans and validating assumptions. We have projects testing and developing new tools and equipment to help us connect customers quicker and cheaper. And we also have projects looking at how we can improve the performance of the grid and the service we deliver to customers.
Because we don't know what customers' energy demand is likely to be in the future, Project FALCON is about finding the best ways to invest in the 11 kV network. The project is based in and around Milton Keynes, and over the next 4 years we will be working in partnership with a number of commercial and academic organisations to develop and deliver flexible approaches to help optimise our electricity network. A new computer system, the Scenario Investment Model, will simulate a number of scenarios of how the UK's energy landscape might look, and for each scenario we will trial a range of real-life engineering techniques and commercial arrangements with business customers to see which works best in each situation. To help fully understand the benefits each new technique could provide, a smart network will be tested across 200 of our sites. Project FALCON will help 11 kV planners choose the best engineering and/or commercial technique to make our network work harder, saving us and customers time and money, as well as potentially delivering environmental and other benefits, such as minimising disruption caused by laying new cables and ensuring power cuts remain a rare occurrence.
Project FALCON, we're looking at 4 different intervention techniques that we'll be implementing on our network in order to operate it differently from how we've traditionally done so. The first technique is dynamic asset rating, where we'll be looking at transformers and overhead and underground linear assets. By using temperature sensors and meteorological data, we'll be able to obtain extra headroom on our network and increase the capacity on our assets without further spend. The second intervention technique we'll be looking at is 11 kV auto load transfer. By implementing a series of different automation techniques on our network, we'll be able to switch around the network with a bit more freedom than we've currently got in order to transfer the load and spread the load across different feeders. The third technique we'll be looking at is mesh networks. By closing the normal open points on our network and paralleling up the 11 kV feeders, we can distribute the energy more evenly across them. The fourth technique is energy storage. By installing a number of battery units across an 11 kV feeder, we can manage the output of these units, coordinate them so that we can lop off the peaks and smooth the troughs of the 24-hour energy cycle. By using these different intervention techniques together, we can look at how they interact on our network and see where they may be used in place of traditional reinforcement in different areas and different hotspots.
We're trialling 2 commercial techniques as part of FALCON. The first is demand-side management, where we ask customers either to reduce their load or transfer their load to their own internal generation. And the second is distributed generation, where we might ask a generator to actually increase the amount of electricity it's supplying, because the changed pattern of flows of electricity across the network might actually help resolve some issues like overloaded sections of network or poor voltage. Now, these are services that are already done for National Grid, so customers might be quite familiar with them. But what's different for us is that whilst National Grid don't care quite so much where this service is being provided, for us it's very important that it's at the right section of network, it's very location specific. And these services require us to be able to estimate the loads on the network and be able to predict network issues before they happen, so that we can call on these service providers and ask them to help us out. At the moment we don't do too much of that estimation. So what we're doing is working on a set of new customer profiles that we can use to predict loads at a distribution substation at any point of time, for any day, for any season. This information will help us manage the network for these new techniques along with existing monitoring, but they'll also be a vital input into the SIM.
So Cisco's involvement within the FALCON project is to build and design the communications network with our partners. The FALCON network will cover 200 secondary substations, 9 primary substations, and this is to enable both the monitoring and control within all the intervention techniques. As I've already said, we're working with our partners to design this secure, flexible and resilient network. It's going to be based on the Internet Protocol IP and also work over a WiMAX infrastructure. That WiMAX infrastructure is going to be deployed as a set of base stations and the pico cells within the primary substations. And that gives us a lot of flexibility, giving us any-to-any communications right through any substation to any substation. And this is really important in some of the intervention techniques, such as the mesh networks, where we're looking at new and innovative ways of looking at teleprotection, new teleprotection schemes. The use of WiMAX has also been significant because it's meant we don't have to dig up the roads to put in fibres or pilot wires. Many of those secondary substations haven't got any communications in them today, or maybe they have very low bandwidth communications. And with some of the techniques such as the auto load transfer, where we're looking at installing synchrophasor measurements, where we're looking at easily 100 kilobits per second per feeder, those legacy technologies aren't applicable. So we really need a technology such as WiMAX that gives us that flexibility, gives us those new bandwidths, and gives us a packet-based network that we can lay on top of that. We also have to think about the security of this though, because we're now going to this packet-based IP network. Security will be fundamental and built into the infrastructure of this. Some other things that we're looking at here as well is looking at things like IEC 6150. So within the substation we'll be deploying those protocols and ensuring that those new ways of working can be deployed right across all of the intervention methods. Cisco's also looking at putting this as a blueprint so that Western Power can take this and really understand how that they could deploy this across their whole estate in the coming years. So really this is a definite forward-looking architecture, as well as being able to take into account the requirements for the FALCON project.
The SIM is a computer-based predictive tool. It finds the most cost-effective way of getting from now to the end of the evaluation period. The SIM is made up of two main components, a predictive engine and a results analysis tool. The predictive engine takes regulatory data, it takes network structure, and it takes load profiles and brings them together to decide if any part of the network would be overloaded. We then apply this calculation year on year going into the future until the network will break. And at that point, we take one or more of the 6 intervention techniques, apply them to the network, fix it, and then we go forward in time from each of those solutions, and eventually we get to the end of the evaluation period with possibly hundreds or thousands of ways of getting to that 25 or 50-year period. What we then have is the analysis tool, which allows the engineer to investigate all those hundreds of results, thousands of results, and find the answers to the questions they're specifically asking. And those questions could be anything from where should I attach a new load to the network, to what should my strategic response be to the introduction of battery energy storage technology.
Project FALCON is a critical step in our Future Networks programme. It's informing long-term investment decisions through the creation of an investment model. It's developing and testing out some of the tools for our toolkit, and for the residents of Milton Keynes it will be improving the level of service and the performance of the network within the city.